Translate. In December, President Joe Biden received the coronavirus vaccine.
In December, President Joe Biden received the coronavirus vaccine.
Language is now set to Chinese.
Translate. I wonder what's happening in Wuhan right now.
我想知道武漢現在正在發生什麼。
Бьюсь об заклад, в Москве холодно.
Quiero mudarme a Guadalajara y comer cerezas o.
In 2020, it was estimated that 34% of the US population owned a smart speaker. Yes, that is 1 in 3 adult Americans own either an Alexa or a Google Home Assistant. That is a massive opportunity to get your skill into people's homes. By the end of this video, you're going to know how to build a skill and monetize it to create passive income. Together, we're going to create a translation skill and go step by step so that you can replicate this on your own. If you watch this video from start to finish, you'll be doing yourself a massive service by familiarizing yourself with the latest emerging tech around voice and in turn, making your skill set that much more valuable. Anyways, guys, let's get started. I want to give you guys a high-level understanding of how this is going to be architected. And I'm just going to walk you through what this is going to look like from a data flow perspective. So we're going to start up in the left-hand corner here, and you're going to see that we have the Amazon device of choice, either the Echo or the Dot. You're going to dictate some text to the Amazon device. So in this case, maybe we say hello, and that's going to be our target text that we want to translate. Well, all Alexa does is takes the audio and uses an ML model to turn that into alphanumeric text. That is using AI. It's done, I believe, server-side, and that's done out of the box with Alexa. And Alexa is going to expose that free-form text to our Alexa developer code so we can start doing something with it. So that's the first layer here. And like I said, it's going to expose that text as a JSON object, and it's going to give it to us in a function so we can do any sort of arbitrary analysis on that. So what we're going to do is we're going to take that free-form text and we're going to immediately forward it to a Google service. I'm not going to do any of the heavy lifting on the Amazon Lambda. We're going to do it mostly on a Google Cloud function. And the reason I'm doing that is because a lot of the logic that we're going to be applying is going to be done with Google. So we might as well just get it into the Google GCP space first. So we're going to send an HTTP request and we're going to post this payload to a Google Cloud function. And all this Google Cloud function is an API endpoint. When you create a Google Cloud function, it spits out an endpoint. So now you can post data to it and you have a server listening. So we're going to post that data and now we're going to have that payload, that text available in the Google Cloud function. From the Google Cloud function, we're going to take that text and we're going to send it to the Google Translate API. And there's a couple different parameters you pass to the API. You say, what is the origin language, what's the target language, and then what is the text that you ultimately want to translate. It's very straightforward. Google has libraries that you can easily make these sort of requests, and so we're going to use those libraries. I like to code my cloud functions in Node.js, so for the sake of this example, that's what we're using. So the first thing is we call the Google Translation API. We say we want Spanish, we're in English, we have the word hello, give me the result. And it's going to say hola. Hola is the equivalent in Spanish. Great. But that is not sufficient, just the freeform text translation, that is not sufficient for Alexa to then speak in native tongue hola back to the end user. Because it doesn't know that hola is Spanish. It's going to try to pronounce that in English. It's going to say hola, which is close, but it's not going to get the proper intonations and accents. So what we need to do is actually turn this Spanish text into audio, into dictated audio using the right accents and the right local dialect. And so we're going to use another Google API for that, and it's called text-to-speech. There's different ways to do it, but the most compelling version of text-to-speech to date, in my opinion, is something called wavenet. WaveNet leverages what are called generative models. Generative models are models where you try to, where you create the model will create a piece of data, and it tries to guess what that data should look like. So for instance, style translations, where you take like a Picasso style, like an artistic rendering, and then you take a new image and you try to transfer that style to the new image. It creates a new output. It tries to guess what that result would be based on learning from the data. And so that's a generative model. It creates new data. Well, you can do the same thing by passing text and training it on people speaking. And the new data that gets created is the dictation, and it's an MP3 file. Generative models are really, really cool because you get new information. And then there's a lot of startups that are working in that space. And so the WaveNet text-to-speech API is able to create synthetic voice dictation that is just more realistic than any other sort of solutions to date. So that is going to output an MP3 file. If we were to play that MP3 file, it would say hola, right? And it would say it the right way, and you could do that for a whole string of text. And then what we're going to do with that MP3 file, because again, that just lives in the Cloud Function instance, and then it's going to be ephemeral. It's going to delete itself as soon as the function terminates. We want to store that somewhere persistent, so we're just going to upload it to Google Cloud Storage, which is just a static storage service, but we're going to upload it to a public folder. So it's going to stand up this URL that can then be accessed by maybe Alexa or whatever the other services that we need to access that. So it's going to upload our MP3 file to googleapi.com/output.mp3, which is Google Cloud Storage. And all we're going to return to our function here is the URL of that file, of that voice dictation. And then Alexa has a native way to play MP3 files using something they called SSML, which is like speech markup language, and you just stuff that MP3, that URL, into an audio tag as the source attribute, and then Alexa will play it back. Now, it won't be in Alexa's voice because Alexa's not reading or reciting anything, it's just playing the audio file, but that's fine. And one of the cool things about WaveNet is actually one of the parameters is the type of voice that you want. So you can get like certain regional voices, gender voices, etc. And it's going to play that audio back to the end user. And so we don't have to do we don't have to recreate the wheel, we don't have to be on the cutting edge of AI. We can just leverage some existing services that are out there to create a really, really compelling service.
Okay, so this is the Alexa developer console. I have two versions of my skill. One is the in-dev skill, which is the version that I actively work on, and then I have the live version. So let's go to the in-dev version, and I'll walk you through how these are set up. So you have these different tabs here. Build is all done within the UI, and this is things like creating new intents, changing the invocation name, and accommodating new utterances and things like that. Code is exactly what it sounds like. It's where we edit our code to interact with those intents or to support those intents. And then test is where we can interface as if we were a user with the skill and see how it functions, and then distribute is how we push it live. Okay, so let's start at the very top here. So invocation name is how your general Alexa is going to know to either pass a command or open up your application. There's a couple requirements, like it has to be like a unique set of words. So for this one, because it's essentially a translation application, the invocation name is my interpreter. So what this means is if you want to interface with Alexa and open my application, you would say, Alexa, open my interpreter. You could say open my interpreter, or you could say Alexa, ask my interpreter, and then you can add the command, translate hello to Spanish or whatever. You can add the command at the end, and that's called one-shot request. And you can do it all in a single command there. So yeah, as long as those keywords aren't taken, I think you're basically able to use what you want there. So I called mine my interpreter. And then let's go down to the intents. So the intents are actually the high-level the high level methods of the skill. Like what can it do? You would have an intent. In my application, I have a translate intent, and that is how you actually pass text to get a translation. I have a select language intent, because one of the things you can do with my skill is say, hey, change language to Spanish, change language to Thai. That needs its own intent. I also have a help intent, so if you don't know how to issue a command, you can just ask for help and it'll tell you what all the commands are. I have a buy intent, which is this skill works in a freemium model, so you get 5 translations a day. If you reach that quota, you can either wait a day for it to reset, or you can purchase an upgrade, in which case you get unlimited translations. So there's a buy intent there. And Alexa offers a bunch of payment APIs that help facilitate the purchase. It's really pretty straightforward. I'm new to the Alexa ecosystem, but I would say they've done a pretty good job here. It's fairly intuitive. It was fairly trivial for me to hop in and start writing code. So I think I'm a new to somewhat seasoned developer is not going to have any issue building an Alexa skill. So the intent is, let's just take a look at the translate intent to give you guys an illustration of how this works. So in order to trigger the intent, you need to have utterances, which are the actual requests, the speech that comes over to trigger that intent. And you can have an array of different utterances that essentially say the same thing. But for this intent, the utterance required to trigger it is translate, followed by, this is called a slot here, which means it's any alphanumeric text that comes through. So anytime you say translate, and then you say anything like hello or translate Coca-Cola, that would trigger this intent because it meets this criteria here. Now, the word translate gets discarded. It doesn't really do anything here. But the slot that says text, that gets used for a very specific purpose here. So there's different slots that you can use. There's like out-of-the-box slots, like here. Let's just open one up here.
Real quick, guys, if you enjoyed this video, please go ahead and like this video. Thanks.
Like social media platform, I don't know why they choose to select these types of slots, but they've clearly chosen them based on like the utility. Things like state season, like any class or category of thing, like a lot of those are set up here. But what's interesting is for what we're trying to do, and I don't think Amazon intends to support this directly, but I was able to kind of hack it. We want a slot that essentially will match on any text, either a word or even a phrase of several words. And Amazon doesn't really support that directly. They don't. There's not one called like dynamic or like free-form text where you can just say, hey, anything that comes after translate, put that into the slot. And that's really what I wanted. But what I did was I dug around a little bit and I found one called search query. Search query kind of does the same thing, right? Like it's as if you were going to go to Google and just search for something. And obviously that query can be comprised of any and all words. So I use search query, and search query works, and it essentially gives me effectively what I want. But just keep in mind there wasn't any very direct way to match on any text, like a wildcard essentially. So I did have to get a little creative there. So this is a very simple intent. You trigger the intent by saying translate, and then you can say either a word like hello, or you can say translate, my name is Tim, a whole sentence, and it'll put all the words that come after translate into this slot here. And what's going to be good about this is when Alexa processes that command, it's going to give us the slot. It's going to give us the text for that slot, which is exactly what we want. We need that text so we can then pass it off to Google for the translation. So I don't think I need to show many of the other intents here. Let's just show one more. I'll show the select language intent. So you can see this one's a little bit more thorough because there's a couple different ways you might want to say change language. So you could say change language to, change the language to, translate to, choose, and then you have the language slot there. And this is a custom slot which I set up called supported languages, which is just an array of custom words. So let's go take a look at that. So I put in the languages that we support, and Alexa will do that matching. And then you can put some other criteria in here. You can say, hey, the slot has to match, because if the person says change language to Yiddish or something that we don't support, it needs to throw a qualification. It needs to throw a validation error to the user and say, hey, we don't support that, or that's not one of the offered slots. And so you can do all that within the slot here. And you can see here, like, Alexa's smart enough to like offer synonyms and other relevant words, but of course we don't want all these. But so this is a custom slot. It's just an array of words, which are languages that I manually put in here. And so to trigger that intent, you say change language to Arabic, and it will just, Alexa will take care of the validation part to say, oh, did the user actually pass a valid language, which is helpful. Okay, so let's go over to our actual code here. I believe you can use a couple different runtimes. I believe it's like Python, JavaScript, and like Java or something. I'm not 100% sure about that. I opted for JavaScript. JavaScript is my forte. I will always use that if possible. It's going to look pretty. It's going to look pretty familiar. Like, it's going to look like essentially a server. It's a little bit different actually, but it's similar. You have your your required packages at the top, and then you have these methods. But what's going to be different is down here. Each one of these is your intent. So I have about 10 or so intents that I support, and if a user says translate hello, Alexa is going to trigger the here's where it gets kind of weird, and I don't think Alexa actually, I don't think this is set up in like the most optimal way, but essentially it starts at the top of the intent handlers here, and it works its way down until it finds a match. So you want your launch request handler, which is if a user says open this application, at the top, and yeah, it kind of checks each of these in descending order until it finds a match. And where you determine if it's going to be a match or not, let's go over to the translate intent handler. All right, so this is the translate intent handler. So like, say a user says translate hello. It's going to check each of those intents, but where we supply logic that will determine if it's a quote-unquote match or not, if it should run that function, is right here. This is the can handle method. And what we're saying is, we're just running some custom logic. So we are checking two conditions. We're saying, is the request type an intent request? Because there are other different types of request types. That's going to be true for all those intents that I showed you. But here's the relevant one. Is the intent name, does the intent name, is it equal to translate? And where are the intent names housed? Back in the intent section. So if we list our intents, there ought to be one called just translate. And there is right here. When it's kind of checking through the available intent handlers and trying to figure out which one should actually handle that intent, this is the logic that we typically use. We say, hey, is it the intent I think it is? Is it the translate intent? And if it is, we're going to run the handle method. So we just have a line here, and this is the same approach I use for basically all my intents. You say, is the intent name what I think it is? Is it the change language intent? If it is, then run that function. And then I just gave everything like legible names here so that like we can kind of like map everything in an intuitive way. So each intent has, I think it's two functions. One is the can handle, which gets evaluated to determine if we should run the handler. And in this case, let's walk through the handler here. I'm not going to walk through every intent, but this is the translate handler, and this is the most relevant one. So one thing I would just call out is the async await paradigm. Very relevant here. Very relevant because we're handling a request, but we also want to make subcommands, sub HTTP requests that are going to take time to execute, and we want to wait for those responses to come back before we proceed. Otherwise, we end up in callback hell. We end up with race conditions, and so all we got to do to accommodate that is throw the async flag in front of that handler, and then within the function, we can start using await. And I'll show you guys when that becomes relevant. So one thing to keep in mind is when the intent fires, Alexa is going to pass an object called handler input. Handler input is a rich JSON object that gives you really every piece of data you would need. It gives you data about the device ID. It gives you all the slots. It gives you the intent name. It gives you timestamps. And it's all there in that nested JSON. So if you wanted to see that, and actually that's what I do here, I log that object to the console for debugging purposes, and we can get into debugging. But just be aware that Alexa sends all that relevant data so you can like run additional logic. And like one of the cool things is, one of the things that I do here is I want to extract the user ID. I want to extract the ID associated with that user because I need to know if Tom purchased unlimited upgrades, and if he did, I will handle the intent differently, and I also will store data under his account. And so one of the pieces of information, that metadata that gets sent along, is user ID, and so I do extract that from that handler object, and I use that. I also log it right to the console, so I can see in debugging. Okay, so anyways, let's step through this function here. So user says, translate hello, right? And I grab the user ID because I want that later. But what I really want is the text. I want that hello text. And it's there. It's in an intent nested property. And it's under slots.text.value. And so this would have the word hello. And again, I log this to the console. So translation text would be hello. And now I begin to prepare my HTTP request because we're not doing the heavy lifting on Amazon. We're going to do the heavy lifting on Google. So I start to construct a JSON object. The action is translate, the text is hello, and then a couple other parameters here, the gender, and this isn't fully supported, but it will be in the future. If you prefer a male or female voice, you can specify that. And then I also want to pass the Alexa user ID to Google because I'm gonna also use Google for my persistent storage database to determine like how many queries a user issued, did they purchase upgrades, do they have premium status, are they a free user, etc. So I pass that data along at all. And then we're going to go and issue this request, and we're going to send it to my cloud function. So I have a helper function called HTTP GET, which is how you issue HTTP requests in Amazon Alexa. And so I'm calling that function here. I'm passing that JSON object. Let's take a quick look at that function. It's at the top here. It should look exactly like the request method for Node.js. Okay, so this function is my helper function that will make HTTP calls. And this one actually did give me a little bit of grief. And the reason it gave me grief is because we had to make it async compatible. And so we're using the promise structure here. And obviously, like when this HTTP request gets issued, you might not always get a response. Like you might get a timeout. And so you just have to properly resolve that. I can share this code. It's not that complicated. So let's take a look at the options parameter here. So where do we want to send the request? We want to send it to this arbitrary endpoint. This is the host name that Google spits out when you create a cloud function. And it's like based on the region, it's based on the name and a couple other things. It also spits out a path. So I called mine NLU_translation. You want to specify protocol. Alexa only supports HTTPS, so don't think you're going to make an 8080 request. You won't be able to. And then we want to, it's a post request. We're going to send that JSON object. Timeout. So here's an interesting thing. Alexa only gets 8 seconds to process a request. So when I say translate hello, from the start of that process to the end, to a user getting a audible response back, it must fall under 8 seconds. If it exceeds 8 seconds, Alexa will throw an error. So what I did was I said, hey, this HTTP request to Google, it must take 7.2 seconds. Because there's still some additional processing that Alexa has to do. It's on the order of milliseconds, but there's some additional processing Alexa has to do. So I give it 800 milliseconds to do that additional processing. But because I want to handle the timeout gracefully. So if Google Cloud Function does timeout, I want to then return a response to the user that says like, oh, that didn't work, try again. So I put that timeout in there. Now apparently, and I didn't get enough time to dig into this, but apparently there are ways to issue requests to Alexa that work around the timeout. You're able to respond when that information becomes available, but I haven't looked into that API. It would be something like a timer. Like say I was to say to Alexa, like set a timer for 20 minutes. Well, obviously it's not going to respond in 8 seconds. There's a method to support that sort of delayed, staggered setup there. And you know, maybe we'd want to leverage that, but ideally the translation happens within 8 seconds, right? Like that, this should all be fairly real time. So it ends up being fine. So we structure our HTTP request, and then we actually we make that request, and we need a couple different responses here. This is the response that we expect if all things go well. Like if we get a response back from Google, then we process it here. But we need to accommodate these two scenarios. One is an error, like the HTTP request, like maybe it can't find the server. And then 2 is a timeout. And so you can see, like I return custom messages like, I had trouble with that translation, please try again. And because I want to handle it gracefully. But let's just look at the response for if it was a proper response. So basically the cloud function will respond with a couple different parameters on that object, and I just look through those parameters. One of them is that the user reached a quota limit. If the user reached a quota limit, then I just define that variable and then I pass it back to our Alexa function. I resolve the promise with that piece of information. 2 is if there was an error, so we can say, looks like the translation service is not responding, and then I pass that back. 3 is if there was no language selected. If the user never selected a language, then let's pass that back. And then finally, if it is successful, we'll pass that back as the message. And there's more data in this object, like obviously the translation URL is going to be in there, but we just do a little high-level vetting here. And then we resolve that promise. That JSON object gets defined to this variable. And so that's actually the beauty of async await. I don't have to use any callback function in my code. This is an asynchronous function. And we don't have to use any sort of nesting callback method. All we're saying here is, hey, issue that HTTP request. It might take 15 milliseconds. It might take 15 seconds. However long it takes, wait for it. And then the response that comes back, whatever gets returned, whatever gets resolved, define it into this variable here. And then when all that happens, move on to the next line of code. That's kind of the beauty of async await. Really helps you write this legible, clear code while complying with the asynchronous nature of JavaScript. All right, and then I log a line breaker here. I log the actual response, and then I log the response type. Because again, the response is a JSON object, and I'll show that to you guys, but you want to log all this stuff because as you're debugging your code, you want to see like where things fail, what are the values that came through, etc. So now I have a little bit of logic here. And this is the same logic I showed you before, which is we want to handle those different scenarios. So the first scenario is there was a quota limit in which like we want to prompt the user and say, hey, you made 5 queries today. So if you want to keep making queries, you got to buy the upgraded unlimited translations. Otherwise, wait till tomorrow and you'll get 5 more queries. The second is if it's a timeout. And then there's the error scenario, and then there's the success scenario. Now, what are we doing in each of these? We're going to define a variable called speak output. Speak output is exactly what it sounds like. It's what we're going to have Alexa speak to the end user. And it comes through as a string, and I could write any text in here. I could say, I don't like what you said, or I could put anything in there. I could put variables in there. It's very powerful. It uses the SSML, which is like speaking syntax markup language or something. And that's thoroughly documented in the documentation, so you can kind of take a look at that and see what the capabilities are there. But we wanted to handle these different scenarios. But imagine the request resolved properly. So the cloud function did the translation, it generated a URL, and that URL should be the MP3 file for that dictation of that translation. Well, it passes it back to Alexa, and it passes it back in this message property of the cloud response. And what we're doing is, how do we get Alexa to speak the MP3 file? Well, it doesn't speak the MP3 file, but you can play the MP3 file using the SSML audio tag. And so what we do is we take that URL, we stuff it into the SSML audio tag, and that'll get played. And then I put a 1-second break in here, and then there's a response that I want to follow up, which I want Alexa to say, like, do you want to run another translation, essentially, and that's what goes in there. Let's see if I define that open-ended. No, okay, so that comes through on the server side. But in a successful scenario, this would be what the response is. And then we return this guy here. So it's always going to be handler input dot response builder. And then you could put a couple different sub methods in here. So the first one is .speak, and then we pass it the variable, so it'll actually speak that variable. And then reprompt is like, do you want to say something after? And if the user doesn't supply any text, do you want to prompt them again? And the answer for us was we do want to reprompt. We want to say to run another translation, just say translate followed by the word or phrase you want to translate. And then you always put get response at the end there. There's a couple other methods that you could call here. I'm not super familiar with all of them, but generally speaking, this would be the structure. And then that's really it. And then like when the user issues a new command, it goes through the whole process again. It tries to find the right intent, and then it runs that logic, and that's how it works. So like let's go ahead and test this in the developer console here. So I'm just going to come over to, actually let me walk through how you save and deploy. So say I were to like add new code here, right? Like console.log, and then let's just do like, we're going to add like a line break in there. You can save your changes, which is trivial. You just click save. But if you want to deploy it to the actual skill to test, you want to click deploy. I always just click deploy because deploy will both save and deploy. Okay, so let's go ahead and test this. I'm going to come over to the test function, and you can hold this down and actually like interact with Alexa using your voice, or you can just type what you want here. So I'm going to do that. I'm going to say, Alexa, open my interpreter.
Hello, welcome to my interpreter. To run a translation, just say, translate followed by the word or phrase you want to translate. To select a target language, just say, change language to Spanish.
So it gives you like the JSON representation of the commands. We're going to say, change language to Russian.
Language is now set to Russian. I'm listening if you want to run another translation. To exit, just say stop.
Translate, hello, how are you?
Привет, как дела?
Привет.
I'm listening if you want to run another translation. To exit, just say stop.
Stop.
Goodbye.
Okay, so yeah, everything looks good. So let me show you something that's useful, which is, what would you do if Alexa threw an error and you wanted to troubleshoot that? The answer is you'd come over to logs, and basically your code runs in a Lambda function. It's managed and hosted by Amazon, but these are the different commands that come over in the log stream here. So this one is probably like the goodbye one. All right, so actually this is the one we want. Okay, so it's going to log everything, or it's going to log what you tell it to log. It'll log some additional stuff, but so like we can see here, this is the kind of stack trace for the translate intent. So let's see here. So yeah, this was the initial request payload. This is that big object I was talking about. It's like all the data that comes over. See the text, how are you? Hello, how are you? So like we can access all that stuff. And remember I printed the user ID. I logged it to the console. That's the user ID. And then we construct this new object. And then we log parts of the object. We also log just the translation text, which is hello, how are you? And that's what we had it translate to Russian. Oh, okay, sorry. This is the object that we're going to pass to Google. So we constructed this object. It has an action translate, target text, gender, Alexa username. And now we posted this to the cloud function. The cloud function returned this guy, an audio URL. And then we triggered the success message, or the success handler. We created an SSML response where we put the MP3 file into an audio tag, and then we had Alexa speak that back and play that audio, and that was the whole thing there. So this is useful just to know if your intent's not working correctly. That's how you would troubleshoot it. But so let's hop into like the Google part. What actually happens on the Google front? All right, so we create a cloud function, and this is our API. This is our server. So the name becomes the route, and if we look at it, we should see the host name, and that's how I knew what to supply in the trigger. Yeah, this is this is like the fully qualified host name. And this is where we would send the data in order for this cloud function to properly respond to it. So let's actually go into the code, and I'll show you how this is set up. So this is a node server, meaning we have package.json, which is our dependencies. You can see I pull in the translation API, I pull in the text-to-speech API, I also pull in storage, Datastore, ffmpeg, right, because we're going to create an MP3 file in the end, and then a couple other packages, supportive packages. All right, so this is the API here. So the top is, you ping data to this, and you end up with a request and response object. I want to do some benchmarking, so I start a timer. These are our dependencies, and then these are helper functions. Get last language by username, I needed that. Upgrade user by username, I needed that function as well. Update stored language by username. Run translation. Okay, so this is like the primary method here. So how does run translation work? Okay, so we post our JSON package to this this API. Let's start by extracting the target language. So we say we're going to run the helper function get last language by username. So you know how we were passing over the Alexa username? Well, we store some data into Datastore, and we remember the last language that a user selected. So I have a function that can extract that from the database. And again, we're using this await methodology, so I can just go and do that asynchronously, and then when it finds a target language, let's assign it into this variable here. If there is no target language, we're going to immediately respond to Alexa and say no language selected, and then Alexa will handle prompting the user to select a language. But let's assume we go into the database and we find that that user had Russian selected. All right, well then let's move on. So wavenet has country codes for each language, and we have those mapped here. We don't support all these languages yet, but we could, and we will at some point. So I just wanted to have that mapping there. And the first step is we want to translate. We're going to want to translate that text. So when I sent over hello, how are you? What we did was we opened up a new translate client, and this is using the translate library, that dependency that I had imported. That's what makes it so easy. And then the text that hello, how are you? We extract that from the JSON payload. Let's create a target language using the wavenet language country code. And then let's select the gender. Right now it's just neutral for everything because I don't think we have support for the different genders. But so we would want to run that translation. So the way you do that is you just call this function translate.translate. So we created the translation object here, and then we pass it two parameters: the text hello, how are you? And then the target language, which would be Russian, or in this case, RU. We need these country code mappings because the Google Translate API uses one set of country codes, and then the wavenet API uses another set of country codes. But essentially, we're passing a country code there. And then it'll return text. It's actually an array, but we're only passing a single translation, so there's only one item in the array. And then we can log that. So we passed hello, how are you in Russian, and then it responded with privyet, and then I forget what the rest of it was, but it's going to pass that text into this variable here called translations. And then now what we want is we want to take that privyet Russian text and have someone speak it in native tongue. And that's where we need wavenet. So what we're going to do is we're going to run through the same process but interface with wavenet using text-to-speech. So we're going to open the client. We're going to start a new text-to-speech client. And again, we're just using the JSON dependencies. That's why this is so easy. And then the way text-to-speech works is we want to create a little JSON object here. And the JSON object is going to have the language code, which is that RU for Russian, the gender, which is, I think it's just neutral for now, and then the name here. So with wavenet, you can specify like which model you want to use, which wavenet model. And that's what name is. And I actually pulled some of those models specifically in here. And like you could not use wavenet. You could just use like the standard convolutional network and things like that. So yeah, that's what the name is. The name is the model, and I wanted to use the one that uses wavenet, so I specified that in some cases. And the name of the models are documented, and you can just pull those in. All right, so now we construct the whole JSON object for the text to speech request. So the input is the text. That's going to be that привет. The voice is what we already. It's this object here: the name, the gender, and the language type, the native language type. And then there's some parameters around the MP3 file that gets rendered. Because again, like what is text-to-speech doing? It's taking text and then it's dictating it. It's going to give you back an MP3 file. We wanted it to be 16,000 hertz. One little caveat is I had trouble getting Alexa to use the 24K hertz. It says in the documentation it can support it, but it did not work for me. So I used the 16K. And then we just issue that command. We say client.synthesize speech, and then we pass that object, request one. And the MP3 file will get saved. Will get saved locally. And so with a cloud function, you get access to this temp directory. Yeah, so with Google Cloud Function, you do get a temporary directory where you can download files, and I need to use that because when wavenet responds, it's going to respond with an MP3, and I need to save that somewhere, at least temporarily. I guess in an ideal world, I could stream it directly into Google Cloud Storage, but frankly, I'm not 100% sure how to stream it into Google Cloud Storage. What I do know how to do is download the MP3 to a local directory, quote unquote local, and then upload to Google Cloud Storage. So what I'm saying here in this line of code here is, and the reason there's an if statement here is because if I'm running this locally, I actually want to use this directory, but if I'm running it in the cloud, I just want to use this directory. And so that becomes the file location object, and then we write the file to that location. We execute the ffmpeg method, and yeah, so by the time this callback runs, the file has been written to that /temp directory, and now we want to upload it to Google Cloud Storage, persistent static storage drive. And so again, I'm using the API. I'm using the package. So I create new storage. I create a new storage instance. I address the bucket that I care about, which is called Alexa Translation. And then I run the upload method, and I say, okay, we just saved the MP3 to the temp directory with that particular file name. Now let's upload it into Google Cloud Storage, and specifically into this directory here. And then once it is uploaded into Google Cloud Storage, that Google Cloud Storage directory is set to public. So any files that get uploaded into it are accessible via other systems, via a public URI. And so we construct the URI, or rather we know what the URI is going to be based on the directory hierarchy and the file name that we've defined. And we turn that into a JSON object, and then we respond back to Alexa finally with this public URI to the MP3. So we're doing res.status, we send a 200, and then we send that JSON object. And then Alexa is going to get a URL, and then they can use the native methods there to actually play that MP3 file. And then we'll do a little cleanup here, and we'll delete the file from the temp directory. I'm not really sure that's necessary since the function itself is ephemeral, but I just did it anyway. And then, yeah, so what I also do here is I store what just happened into Google Datastore. Datastore is more like a MySQL database, although it's a NoSql database, because I want visibility into how people are using the application. I want to know what queries they're running, what languages they're using. I want to benchmark how long the whole file execution took, and so we get that visibility by storing it in database. But we do that after we've already responded to Alexa. And then basically, once Alexa gets that translation method, all Alexa gets back is a URI. And then how it's able to play the URI to the end user is
using an audio tag. So the SSML markup, typically you put text in there. Like you could say, I had trouble with that translation, please try again. But in this case, we don't have text to give Alexa. We only have an MP3 file, because that's what wavenet is doing. Wavenet is taking the translation and reading it in the colloquially correct dialect. So we can't use text. We have to use an MP3. And the way you get Alexa to recite or play an MP3 file is via this audio tag. So see what we're doing here? When we get the response back, which is the URI, we stuff it into an audio tag. And then we say, Alexa, speak that output, and she'll play the audio, the MP3, and then we wait a second, and then we also follow up with a response like, would you like to run another translation? And that's how it all works. And actually, let's just show the Google storage. So if I go to storage, and I go to Alexa translation, again, this folder is public, see, public to the internet. And these are all the translations that we've done. And we just give them a unique hash, so when we're responding, we know which one is which one. And we could delete these like pretty much right after they're recited. But and that's probably something I should do. But like if I play one of these,
यह एक अच्छा फोन है.
It's just a translation that we set at one point. And Alexa is able to access these. So that's really the data flow. I don't think there's a whole lot more. So one of the things about the Google Cloud Function UI here is that the workflow in my mind is not ideal, because basically you have to edit the code, and then you have to click deploy, and then you have to shoot an API call at it and kind of see if it responds in the way you'd expect. And deploying takes like 15 seconds. So imagine every time you make a code edit and you want to test it real quick, you have to wait. For me, I like to break it. I like to throw stuff against the wall and see what sticks. So that's the kind of coder I am. So it just doesn't work very well for me. So what I've done is they give you the option to download your Cloud Function locally and test it in a local environment. And so that's actually how I did the bulk of my development here. So if I go over to terminal here, and actually as I mentioned, there's like two different pieces of code, because we're building an API. We're building a ephemeral function that runs in the cloud that responds to incoming requests and then deprovisions itself. And that's what's going on the left side of the screen here. So this is the same code that's in my Google Cloud Function in the UI there. So I just want to keep that up so that I can edit this as needed. Now we need a script to send data to it. And this is what's going on the right here. And this is what essentially Alexa is going to be doing. When you interface with Alexa and you issue a translate or a set language or upgrade account command, it's going to be posting an HTTP request. So I just came up with a little script here that modifies some of the attributes. Like instead of posting to the Cloud Function, let's post locally to our local Cloud Function. Because what we're going to do is we're going to deploy this Cloud Function locally on my computer, and then it's going to be much easier to do our development. So one thing that we can do, which is kind of cool, is we can open up terminals right in VS Code. So if I click terminal, and specifically we want two terminals. We want one to stand up the Cloud Function, and then we want another to execute our send Alexa request script and interface with that Cloud Function. So let's do the first part. We're going to use this npx Cloud Functions framework, and then you just pass the name of your function. And in this case here, it's translate. And what that's going to do is it's going to go ahead and stand it up locally. So now we have a server. So instead of the Cloud Function listening on remote host in the cloud, it's listening on a local host. And now we can send some data to it. And so in the right hand here, I'm in the directory here, and this is my test script, send Alexa request. And I can do different things. I can test the set language method, the translate method, the upgrade user account method. But right now I have translate set here. And when I have translate set as the action, you pass a JSON property here. It's the gender of the voice dictation you want, a faux Alexa username,
but most importantly, the action, which is translate, and then some text here. And I can say, hi, my name is Tim. And I can go ahead and save that. And if I run this script, it's going to post that data to the local cloud function, but it's also going to retrieve the MP3 file. And I have a helper package here that will play the MP3 file. So like I don't have to trifle with a lot of the intermediary steps. We can just go ahead and play the response. So what I expect here when I run this script is it's going to translate from English to Thai, and it's going to translate this text here, which is, hi, my name is Tim. So let's go ahead and do that. So I'm just running node send Alexa request.
สวัสดีฉันชื่อทิม
So that looked good. And this is how I can like easily test my file. And if I wanted to update my script here, all I'd have to do is kill the server, update the code, and then redeploy locally, and I can run another file at it. So I can say I am writing code on my computer in Boston. And you might have noticed it wasn't a male voice. That's because I don't have support for gender quite yet. Although the text-to-speech API should offer that support, so we can use it at some point.
ฉันกำลังเขียนโค้ดบนคอมพิวเตอร์ในบอสตัน
So this is the workflow that I like. And basically, once your cloud function is in a good place, all I have to do is copy this cloud function and then paste it into here. And we can like quote unquote deploy. So I just want to show you that workflow. I think it's far better. And what I can do is maybe I can share this directory here so you guys can use that as like a boilerplate. So that's the cloud function piece. There are some intermediary things going on here. Like we're not just translating and like loading the MP3 into Google Cloud Storage. We're also doing a little bit of tracking because I want to know when folks are issuing queries. I want to know when people upgrade. I want to know their usernames, and I want to actually know the queries themselves because maybe in the future we can offer like support for caching queries and things like that. So that's where this Datastore piece comes in. Datastore is Google's NoSql database, and basically I just use this as a way to log data. So you can see here, like when a user changes their language selection, we set that into a database. And actually I can go ahead and show you guys that database. So if I go over to Datastore, I set up I think 3 different tables. This is the Alexa user language selection table. So these are Alexa usernames. These are timestamps of when they were changed. And this is my test script right there. And you can see my most recent language is Thai. And these are languages that the users have set. So when these users log back in or when they start using the Alexa skill again, I already know their language. And I've stored that in persistent memory, not just like transient memory. So we have a database here, and that's helpful. We can do the same thing for knowing who's a premium user. So these are all premium users. And then also, we might want to at some point export analytics around queries themselves. The types of queries, the most common languages. I'm benchmarking how long it takes that whole function to run. And you can see here, like sometimes it gets a little high, like 5 seconds is a little slow. But anyway, these are queries that users have run. And so like maybe we can just use this data to better inform product decisions moving forward. I'm not sure if there's much else. Hopefully we've run through the broad architecture here. And I guess my point here is that you can get pretty far without having to build code from scratch, like not having to reinvent the wheel. We're using Alexa, which is a powerful platform. We're using GCP, which is powerful, and the ability to create these ephemeral functions and easily set data into these small databases. And then we're also using the heavy lifting of the translation APIs. Those are things that I would never be able to build from scratch. They're just far beyond our level of expertise. But at the same time, we can leverage that kind of groundbreaking work that the research teams have done to build things like wavenet, to build things like Google Translation and that sort of thing, because they're all accessible via API. So, you string together these off-the-shelf solutions and you come up with a really powerful synergy. And I think there's a case to be made for that methodology and that kind of product development, as opposed to having to build stuff from scratch all the time. Anyways, I think that's all I have for this. Feel free to ask questions. I'll release as much of the code as I can as possible. And happy coding.
If you have any questions, please throw those in the comments. I reply to each and every comment.
Alexa, open the pod bay doors.
I'm sorry, Dave. I'm afraid I can't do that. I'm not Hal and we're not in space.